All right, so today's topic is going to be the quadratic formula. So, it maybe you may have thought it might be nice if we had just one thing that we could go to every single time if we're trying to solve quadratic equations instead of factoring sometimes, and then if factoring doesn't work, then we do completing the square. And then if completing the square doesn't work, then what? So we wanted to come up with some sort of formula that would work every single time. So if we have some function, we'll call it f, and it's in our standard form, ax squared plus bx plus c. Well, let's just try solving this and see if we can figure out a value or something we can use for just x. So if we set, whenever we're trying to solve these, remember we always set our function value to 0. We want to find those zeros of the function. 0 equals ax squared plus bx plus c. So now our goal is to get x by itself. And so the way that we're going to do this is I'm going to go ahead and I'm just going to subtract c over to the other side. Minus c. All right, equals ax squared plus bx. And then I want to try to use completing the square to get x by itself. And in order to do that, the number in front of x squared has to be 1. So we're going to divide both sides of our equation by a. So we have negative c over a equals x squared plus b over a times x. So then we are going to figure out what we need to add to both sides of our equation in order to complete the square. So we're going to take our number that is in place for b right now, so that's b over a. We're going to divide that by 2, and we're going to square that. Remember that if you have a fraction divided by a number, it's going to be the same thing as if you took that number and multiplied it by your denominator. So we're going to end up with b over 2a squared, which there's really no nice way to write it, so we're just going to go ahead and add b over 2a c over a equals x squared plus b over a times x plus b over 2a squared. Whoop. All right, whoopsie daisies. I forgot to put the parentheses over here. So let's clean up a little bit. Let me just scroll up just a teensy weensy bit. So b over 2a squared is going to be, I can get rid of the plus, there we go. So we're going to have b squared over 4a squared. And then this should have been a minus sign, minus c over a. And that's going to equal, if we factor this left side, or factor the right side, is going to be x. We have a plus sign here, that's going to come straight down, stay a plus sign. And then b over 2a. That's going to be squared. So then we take and we can find the square root of the entire right side. Actually, you know what? Before we do that, let's see if we can get this into be one big fraction. Okay? So we're going to take b squared over 4a squared minus, in order to get this a to be a common denominator with this guy, we're going to need to multiply this a by another a and multiply it by 4. So we're going to take and we're going to get 4a squared on our denominator. And since we multiplied by 4a, we multiplied our denominator by 4a, we have to multiply the top portion of our fraction by 4a. So c times 4a gives us 4ac. And then once we have that, we can subtract these two and turn this into one big fraction. So that's going to give us b squared minus 4ac, whoops, 4ac all over 4a squared equals x plus b over 2a squared. Scrolling up. So then we want to take and get this guy by itself. So we're going to take the square root of both sides. So when we take the square root of the left side, we can split that square root over onto the top. So square root of b squared minus 4ac over the square root of 4a squared. Well, we have a nice little square root on the bottom here. So I'm going to go ahead and just clean that up. Square root of b squared minus 4ac all over square root of 4 is 2. The square root of a squared is just a. So that is our left side equals our right side, which is now out of the parentheses, x plus b over 2a. And now we want to get x by itself, so we're going to go ahead and we're just going to subtract b and b over 2a from both sides. So we're going to have negative b over 2a plus the square root of b squared minus 4ac over 2a, but it can't just be plus because remember whenever we take a square root it can be either positive or negative. So b over 2a plus or minus all the other stuff is going to equal x. And that gives us our quadratic formula. Okay, so if you want a whole like too long didn't read type thing, this guy right here. I'm gonna write it in gold. Whee! Or tan, whatever color you want, but the thing says that this is a gold pen, so I'm writing with a gold pen. All right. So our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, that whole thing over 2a. All right, and that'll give you solutions for any quadratic equation that is written as a in standard form. Once it's in standard form, you can take whatever value is for b, plug it in here and here, take whatever value you find for a, plug it in for a, plug it in for a, and then whatever value c is, plug it in for c. Okay? So this is our quadratic formula. So now that we have this quadratic formula, we want to be able to start doing things with it. So let's take a look and see what this looks like while trying to work with a quadratic. So let's say we have x squared plus 10x plus 2 equals 0. We want to solve this and find out what values of x make this true. So we can plug things straight into our quadratic formula. X equals negative b, 10 is b, so negative 10 plus or minus the square root of 10 squared minus 4 times a, in this case, is 1 times c, which in this case is 2, all over 2 times a, which is 1. Right? We have a, b, c. The only way you can put a 0 in, I know there's nothing here that looks like any numbers for a, but remember we have to put a 1 in there. The only way that you could put a 0 in for any number would be if you had something like x squared minus 3. If you had something like that, x squared minus 3, then you would 0 would be your value for b. Okay? So that's a way that we can use this equation, taking a look and finding those numbers in front of that represent a, b, and c. So now we want to just start turning the crank until our equation vomits out a number at us, or some numbers at us. So we have negative 10 plus or minus the square root of 10 squared is 100 minus 4 times 1 times 2. 4 times 1 is 4. Yeah. 4 times 1 times 2 is 8. Wow. Over 2. X equals negative 10 plus or minus square root of 92 over 2. So then x equals, let's see if we can figure out square root of 92. So let's see, does 4 work? 4 into 92, yep, that works. That is 23? 23? Yeah, so we can split the square root of 92 up into 4 times the square root of 23, which then just becomes 2 times the square root of 23. So we have negative 10 plus or minus 2 times the square root of 23 all over 2. And if we break this up, we can also get negative 10 over 2 plus or minus 2 times the square root of 23 over 2, which simplifies down. Negative 10 divided by 2 is negative 5. plus or minus 2's reduce out is going to be 5 plus or minus the square root of 23. So this is why we did the whole simplifying radicals thing yesterday, because if we didn't do that, you can make your argument either way. But if you just stop right here, I would say that this is a lot less nice of an answer. I would say that this guy right here is a lot less nice of an answer than this guy right here. Okay? That's just my own personal opinion. They're both technically correct. They're both technically the right numbers, but being able to simplify it gets it a lot cleaner, and also makes it a lot nicer if you have to check your work, because the way you would check your work is by plugging these back into the equation and seeing if you get a true statement. Okay? So let me give you one, and you can try it on your own, and then we'll see. We'll make sure everybody gets to the same spot on the other side. All right, go ahead, and I would like for you to use the quadratic formula to take and solve this equation. Solve this equation for x. Find values of x that make this a true statement. All right, give this a shot, and pause the video when you're all done, or pause the video so that way once you finish, you won't be spoiled with the answer. All right. All right, welcome back. Here's hoping this is what you got for your answer. Hopefully you got that x is equal to 4 plus or minus the square root of 10 over 2. Values we're plugging in: b is going to be 16, a is going to be 2, and c is going to be 27. Now remember, even if we're writing this a little bit strangely, so like say we had 27 plus 2x squared minus 16x, a, b, and c don't change. A is still the number that's attached to x squared, b is still the number that's attached to x, and c is the number that doesn't have an x. So make sure that you're paying attention, and all those numbers are still in the same spots, are still applying to the correct variables. All right. By working all this out and by turning a bunch of cranks and plugging a bunch of numbers into calculators, hopefully you got to 16 plus or minus the square root of 40. 16 plus or minus the square root of 40 is equal to 4. Hopefully you found this. And then if you got a little stuck going from here, that's okay. That's just going to take some practice. That's where I came from here up to here. I wanted to figure out what the square root of 40 would end up being equal to. So I said, okay, 40 splits into 4 times 10. 4 is a nice perfect square, becomes 2. 10 kind of stuck in, kind of doesn't have any nice perfect squares, so we ended up with 2 times the square root of 10. I split this up into two fractions, 16 over 4, plus or minus 2 times the square root of 10 over 4. 16 divided by 4 reduced to 4, and then 2 times the square root of 10 divided by 4 is 10 over 2. Okay? Or square root of 10 over 2. So that's how you get your answer with these. Now, there are times when you'll end up with, sometimes you might end up with something like square root of 216 minus 256, and you'll end up with a negative underneath the radical in here, so that'd be negative 40. Remember, that negative, everything else stays exactly the same. It just means that your answer is going to have I involved. It's going to be an imaginary number. Okay? So this quadratic formula actually gives us a really, really nice thing. Most specifically, that nice thing is this part right underneath the square root right here. This b squared minus 4ac number. Okay, that's super duper convenient for us. Okay, because that allows us to take a look at some really, really nice, really interesting things about a given quadratic we might be looking at. So let's say that we're looking at a quadratic. Let's say we're looking at x squared minus 8x plus 10. All right. So this part underneath the radical here, the part underneath the square root, is called the discriminant. And the discriminant has some nice features about it. If we find that, I'm going to use just the letter D to represent our discriminant. If the discriminant is greater than 0, so the part underneath the square root, if it is a positive number, that means that we have two real solutions. Or if our discriminant is positive, we're going to have a graph that crosses the x-axis twice. Okay? If our discriminant is exactly 0, that means we're going to have one real solution. And that one real solution means that we're going to have a graph that does something like this, where it just touches and turns and goes the other direction. It's just going to touch just once on that x-axis. That's if our discriminant is exactly equal to 0. If our discriminant is less than 0, so we have a negative number for our discriminant, that means we're going to have 0 real solutions, and we're going to have 2 imaginary solutions. Okay, so it's real nice for a problem like this over on the left side here. If we just wanted to say, is this going to cross the x-axis? We could check the discriminant with this. Okay, so if we have x squared minus 8x plus 10, we're going to say, all right, what's b, what's a, and what's c? Well, this is a is 1, b is 8, and c is 10. So we're going to say, all right, b squared minus 4 times a times c. So b is 8, so negative 8, I guess, squared. Doesn't really matter when you're squaring something, whether it's positive or negative, minus 4 times 1 times 10. So 64 minus 100. That's going to give us a number that is negative 36, something like that. Negative 36. So when we have 64 minus 100, wow, we're going to end up with negative 36 as our answer, or as our discriminant. Since this is negative, our answers are going to have 0 real solutions. Our answers are going to not be real numbers, which is nice if you think about the basketball problem, or not the basketball, but the bell ringing problem from a few nights ago, where we wanted to see how hard, or if a person would have to ring that bell. You don't actually need to find out what the number is. We just want to know, are they going to hit it? So this was the equation we were given for our for that function, that whether or not we're going to ring the bell, and they said that this d represented the distance between the bell and the puck that's trying to ring the bell. So the puck will ring the bell if we can reduce that distance and make it 0. If we can get that distance to be 0, the puck will have hit the bell and it'll ring. So 0 equals 16 t squared minus 32t plus 18. So if we just use this idea of the discriminant, if we take b squared minus 4 times a times c, and we get a positive number, well, that means we're going to ring the bell. If we get 0, it means we're going to ring the bell, but just barely. If we get a negative number, we're not going to ring the bell at all. It's never going to actually get there. So 32 squared minus 4 times 16 times 18. So 32 squared, after some off-camera math, 1024, and 4 times 16 times 18 is 1152. So since when we subtract these two, we're going to get negative 128. Because our discriminant is negative, there is no real number value. There is no amount of time that we can use to take this distance from the puck to the bell and make it 0. There's no real numbers we can use for that. Okay? So with those ideas, complete the attached assignment. Guys, have a wonderful day. I will see you during our hangout, or possibly tomorrow. We'll see. Have a great one. Bye, guys.